everyone. Good evening. Welcome to this episode number 6 of Ozzy Game Dev using the AProcessing framework. And of course, we continue with the racing car game. With me, of course, there's Ozzy. Let me make him able to talk. Hello, Ozzy.
Hello everyone.
So,
Thanks again for having me for my car race series.
okay. So, as always, I start with my ritual, but before that, please note that I am in a different location again. I am back home. You can see the stuff behind me, the Amiga books. Hello, Dogster. Good evening. And let's see, will I manage to share that? There's my Amiga 4000. Here, the black thing, that's my Amiga 4000 in the corner. And I cannot move a lot the laptop, that's why. And yeah, then there are the Amigas. And there is more on this side anyway, just for the sake of showing them my babies. So let's go to my the usual ritual by going to my browser. Okay, there you go. So, as always, all I ask is to subscribe and like my YouTube channel. Ozzy, you are subscribed to my channel, right?
I think yes. For a very long time.
I'm joking.
From the first episode.
Really? Oh.
I think yes.
Wow. So, besides that, remember that under each video there is, for example, this one is an Ozzy one, so there is a link to Ozzy's GitHub and also to this episode source code. And then of course there is my Facebook page. Please subscribe or join and follow. Subscribe to the Phase 101 Facebook group and to the Commodore Dev Phase 101 group. If you write to me on let's change it a bit. If you write to me on Facebook, I do reply, but I take my time. But if you join Discord, then I reply immediately. May I remind you also that I have this page that can help you to learn to code for the Amiga, which I'm going to share. Oops. I need to refresh it. However, it's quite a long one. If you type !" book page, it will also show. I do have a short link to it, but I forgot what it is, to be honest. But yeah, you can use a shortcut to it. Anyway, so we jump here. You see me close, and in the meantime, I prepare the notes of Ozzy. Okay, so there you go. And Ozzy, you can start with the introduction of today, episode number 6.
Okay, so it's showtime. And so what I'd like to show today is how I solve, or I think it's my attempt to solve, I think the most crucial feature of my car game. This is a feature that was missing in the previous versions, but I think without this feature, the game, it's not so funny to play. And I'm talking about car collisions, because if this game is a multiplayer game as intended, the fun part comes when your car bumps into another car, and then maybe the other car takes a certain path which is unforeseen, for example, and then you laugh at it because you forced the other car off road, for example. So it's not an easy task to me, because this collision detection and collision reactions involve physics, and of course I do not know anything about physics and math, but I have a strong weapon, and the weapon is the internet. It means that I can start researching and read some papers, some documents on the internet, just to see how the other developers solved this problem. Of course, the vast majority of the links I found on the internet were referring to game engines like Unity or Godot, and in this case, they just tell you use this class, this object, and it will take care of the physics for you. You don't have to know anything. Of course, this is not true when you program on the Amiga, and especially if you are a beginner like me and you don't have any tool, you just have your hardware manual and some M60A instruction. So I had to figure out on my own a method, something that could work, could be pleasant to you, not realistic, of course. So the physics that I painted inside the game has nothing to do with reality, no science fundamentals, but still it's something that I like, and I try to apply my best to the game. And so what I would like to do now, I would like Phase just to try to launch the game.
Yeah.
And I know it's difficult because even I am the creator of the game, and I am not able to control two cards at the same time, but you can just take one card and try to make the card collide with another card, just to see what's the final result of my code.
Mm-hmm.
You can just enable 4 cards, and then you just control one, and you just try to make your car crash into the others, just to show how it works.
So I can leave the controls as they are right now?
Yeah, you just go to start, and then you will control car number 1, and you intentionally go into other cards.
Yeah. So I go to the one in front of me because I'm the black car.
Oh, but this is the debug version, actually.
Really?
This is the debug version. You see that all cars are, the corners are wrong.
It's not RC underscore debug what I run. Let me go back.
It should be RC32.
I don't know if you saw, but I run RC.
Yeah,
Okay,
let's
RC.
run RC32.
Yeah,
It's the 32 colors. The other
yeah.
is full of debug stuff. It's the
Uh-huh.
dual playfield version.
Okay. Okay. So, what I'm going to do, I'm going to reduce a bit the sound of the emulator.
Yeah, you can mute it.
No. I will just. Where is it? F12. And we make it the sound a lot less. Let's say 15%. Yeah, a lot better. So, let's see what happens if I crash. Oi.
Yeah, you can collide with any car you want.
Uh-huh.
Even with the green one or the blue
I
one.
want to play it. I want to see how I manage this, because I'm feeling that it has improved, because look, normally I do not even do this. Come on. No, it has improved. I am managing to play it.
Yeah, improve some way, yes. But I'm stronger.
Oh, it also bounces when you hit one of the things.
This is something that was already implemented in the past.
Yeah, but it wasn't so clear then. Oops.
Yeah, I make small adjustments from one version to another, but last week I was focused mainly
Oops.
on what happens if you bump into.
Yeah, I'm attached to it. Hey, I made it. That's it. No?
Good.
So, I press escape now.
Yes, you can close.
Okay, so let's go back
Oh,
to.
of course, the interesting part comes if you are able to drive two cars at the same time and
Yeah, of
see what
course.
happens when both of them are in movement, but this is hard for anyone. So
Yeah.
I asked my daughters to play with me and to crash into each other to see how it works. And actually, I'm quite satisfied of the final outcome. So mm, this was implemented 2 or 3 weeks ago. I already forgot almost everything, but I will try to explain at my best how this works. So please go to page number 2. I will start commenting my code. So, okay, for most of you, probably this will be very boring because it's just pure assembler. And so I will just try to comment at my best this part. And this is where all begins. This is the main game loop. And if you remember from the previous episodes, what I do is at every frame, so 50 frames per second, I cycle through each car. So there are 4 cars, so you have 4 iteration loop. And for each iteration, I just read the controls of the car and then I calculate the movement according to to the status of the car. Then I update timer and do some stuff, and then proceed with the next car. And when all the cars are finally processed, I just wait the vertical blank and then start over again. This is the main body of the game. Inside this loop, so inside this for each car loop, there is another loop which is nested, and this is the second loop. And what I do here, I cycle again for each car, and this is at the top. You can see there is a call to the move function. So the first thing, I calculate the movement of the car, where it should go at the next frame. Then I start the iteration, because you see the last line is a debra, and debra is what I usually do for, let's say, four loops in C, and for me it's a debra, which is very convenient. And for each car, I do some checks, preliminary checks. The first check is I check if I am comparing A1 to A0 with A1, because A1 is the pointer to the car which was moved before, A0, sorry, and A1 is the other car. So if it's the same car, I just keep, because it makes no sense to check if a car is colliding with itself. Of course it's colliding, it's the same object, it's the same car, and it will always collide, and makes no sense absolutely to elaborate this thing. So there is a BEQ, and so I skip to the next iteration. The second check is the bit test, these 6 cards in play plus 1. These cards in play plus 1 is an address in memory, and it's just a map of the card that are actually playing the game. Because if you remember, at the start there is an option screen, and you can disable the card. And so each card is represented by a bit inside this memory area. And of course, if the car is not playing, it won't be shown, it won't be displayed, it won't be calculated. It makes no sense to check if the player is colliding with this other car. And finally, I just jump to the new function in the routine, which is a check collision with other cars, which is implemented in a separate file. And then I start over again. So this DSR is executed quite often. And at this time, you may wonder why I didn't take advantage of the hardware acceleration of the Amiga. And the reason is that for now, I just want to check if the car is colliding on my own, because the hardware, or the Amiga hardware, just gives you a Boolean value. It just tells you if the sprite is colliding with another sprite, yes or not. If yes, he doesn't say anything about how it's colliding, for example, how many pixels are overlapped, for example, how the car is into the other, for example. So this is calculation, these are calculations that I must do anyway because my algorithm requires this data. So since I have to calculate all this data, I just say, okay, I do all the checks on my own for now, and the hardware, condition hardware from the Amiga could be used in future for optimization, of course. Another thing is that since my goal is to rewrite this game also for RPG version, this is something that I would like to do. And when you program RPG, as far as I know, there is no, let's say, collision concept. Of course, if you are displaying data in a graphic card, you can take advantage of the sprite hardware of the Amiga because it's managed by this card. So I would have to write all this extra stuff anyway. So for now, this is my decision. I know that from optimization point of view, it's not great because there are a lot of checks, but still I see that my stock A600 is not struggling with the game. So even if you play with 4K, which is the worst case scenario, I don't see any performance issue. So for now, I'm going like this, and maybe in the future I will just optimize using the hardware. So this is the reason. Okay, we can go on to the next slide, and I will just explain what's inside this check collision and how I check if there is a collision or not without the Amiga hardware. And this is a concept that it was again taken from the Nature of Code book from Schiffman, but this is it's pretty common knowledge. It's nothing groundbreaking. You can find the same concept in any book. This is the concept of difference of a vector. And what my point here is, let's say that we have coordinate 0, 0 on the top left, which is, of course, the first byte of your bit plane. And the two rectangles are just representing my cards. So let's pretend for a moment that the rectangle are cards. Each card has its position vector. There is a pink one, the card 1, which is the card pointed by A0, for example. And it has position 100, 200. So let's say that this is the vector that describes this black line, is the vector that describes the position of card 1 relative to upper left of the screen. The origin of the axis is on the upper left. And the second card is 300, this is the x value, of course, and 150 is the y value. And so again, we have another vector, which is describing where is this card, how must be painted relative to the origin. If we subtract these two vectors, so the blue one and the black one arrow, we get the distance of the two cards. And if you see, I painted a line, a dotted line, the dotted pattern in green, which is the x distance, and the yellow one is the y distance. And what I do is I just call my subtraction routine, which is very trivial, just subtract the two vectors.
Can I stop you a second?
Yeah.
So 0, 0 on the screen, exactly, where is it?
0, 0 is the start of the bit plane.
Yeah, so it is in the upper left hand corner of the screen.
Yes.
Okay. No, I know you said it, but for a moment I was thinking if zero zero was somewhere in the middle of the screen. But okay, we got you.
It depends. This is just a point of reference.
Mm-hmm.
In this case, how I describe position on my game
Mm-hmm.
is with vectors which are relative to the upper left corner.
Mm-hmm.
In the past, I remember I showed you some concept of
Yes.
translating the origin.
Yes, that's why I asked.
And I usually, in demos above all, I translate the center to 160x and 128 on the Y. So I have the 0 point exactly on the center of the screen. This is usually what I do in demos.
Mm-hmm.
This time, I decided, because I like this way,
Mm-hmm.
I decided to leave the center of my word on the top left corner.
Right. Yeah. Okay.
Okay?
Ciao,
So
few
if
bit. Hello. Sorry.
So, yeah. Can I continue?
Yeah. Of course. Yes.
So if I say that car 1 is at position 100, 200, it means that it's at pixel x 100 relative to the upper left corner of the screen. So to the origin of the bit plane, you take the origin of the bit plane, you add 100 bits because it's planar mode, it's not chunky here. You add this value and you find the position of the car, the x
Mhm.
position.
Sure.
And the same applies for the y position.
Yeah.
And this pair of values just gives me a vector, the black vector. And the same concept applies to the car 2. So what I was saying is that if you subtract this value, the resulting vector is the red one, right?
Mm-hmm.
So for example, distance vector is you take car 2x, which is 300, and you subtract with car 1x, which is 100.
Yeah.
The result is 200. Okay? And so this is the length of the green dotted line.
Mm-hmm.
And the same thing is for the y. So I take 150, which is car 2y, and I subtract with car 1 y position, and the result is minus 50. But of course, in order to have the distance, I must have the absolute value. So what I do, I implemented this is why you had some trouble with the AProcessing framework today.
Yes, I noticed.
Because
The
you
maths.
need my math library
Yes.
in order to compute the absolute value of a number.
Yeah.
So I had to include another version of AProcessing.
Yeah. In the green line where you say have x distance, is that correct? 300 minus 200.
It's minus 100.
100. Yeah. So that.
It's inverted.
Yeah. It's because up. You know, in red on top of it, you wrote 300 minus 100, but then you wrote 300 minus 200.
Yeah, I inverted the values.
Yeah.
Good catch. Thanks for noticing.
Yeah.
I should read my notes.
Yeah, it's a typo. Doxter said that in his game that he's doing for the Amiga, he used this type of collision. I assuming he used vectors to calculate the distance, and if one of your sprites is close or at the same position, so that means collision with the other sprite. Assume you did that, no, Doxter? Hello, ProtonFig.
So this is my method. If you watch, if you look at the bottom of the screen, there is my if statement to check if they are colliding. And for me, this is the simplest method and works just fine.
Yeah.
It's not by me, it's something that's a formula that I found on a game. It was written on C. I just translated to the
Assembler.
And the formula is if this x distance, which is the absolute value, so the green dotted line, is greater or equal than the card1 width divided by 2 plus card2 width divided by 2, and if the y distance is greater or equal than card1 height divided by 2 and card2 height divided by 2, it means that there is no collision. Right?
Yeah.
So it means, on the contrary, if this condition is false, there is a collision. So this is the point, and this is, for me, it's quite easy also for the Amiga to compute, because we are just comparing two values. So a CMP and a BLE.S should be enough to compute if we are colliding or not. And of course, if we are colliding, we apply some additional logic because we want the cards to behave like we want. And so in the following slide, there are 3 slides I just
so
described.
shall I change? Shall I change?
Yeah. Yes, go to the next page. And this is a collision example. So again, the rectangles are my cards. It's the representation of my cards. And this is an example of 2 cards colliding, because as you can see, the pink card 1, is colliding with card 2. And in this case, I calculate again. This is the same formula that we saw on the slide before. We just make the subtraction. So 110 minus 100 gives you 10. And card 2 is y is 192. Minus 200 is minus 8. Of course, you have to get the absolute value. And you get x distance, which is equal to 10. And the y distance is 8. And I think this time my math is right. I think at least.
Doxter is saying, I don't know if you can see his message, the width is always divided by 2. So that could be car underscore width plus car 2 underscore width all over 2.
Yeah, yes. You have to divide the car width divided by 2. So there must be its half, because it's the projection of the rectangle. This is how the formula works. It makes sense to me, actually. I'm not good enough to give you a math explanation why we must compare against the width divided by 2. I can give you the documents that I read, so you can study why the formula is written like this, because I'm just doing like a parrot. I'm just copy and pasting the concept and translating to assembler.
So you found a document that was specified in C that then you translated into assembly, and that's what you are referring to?
Not exactly. In this particular case, I just found out a document which was describing the idea without code. There was some
pseudocode, yeah.
Pseudocode, yes, but of course it was nothing Amiga related, but still it was something that worked for me, so I just borrow it, let's say, the concept. And there is this formula, and I just took this formula from, I took for granted, which is right, and actually it works. And so that's it. And in my case, this is even simpler because all my cards have they share the same sprites, and this means that the card size, the card width, and the card height is always the same. I could simplify this formula even more and just get rid of the divided by two, for example, because I know that card one width is equal to card two width. So, but of course, if in the future I will decide that I have a track and a Formula One car, the track probably has greater width, and so this formula will help me a lot. So I took like this. I just left the formula like this, and the code is implementing this. And so 10 and 8, and the x distance is 10, and the y distance is 8. And the car width is 20, and the height is 10. So I just substitute these values to the general formula, and the final result is 10 greater or equal than 10 plus 10, which is 20? Of course not. So it's false. So I don't even need to check the other condition. I know that these cars are colliding. And so this is the general idea. And so all this part is the substitution of the check on the Amiga hardware. And I need all this data because the x distance and the y distance, these values will be used later to separate the cars, because I don't want the car to overlap. I will just adjust the position just to prevent that the collision takes more than one frame. So this is the idea.
ProtonFig is saying that he spoke to Dario about 2 months ago. He said it has nothing to do with the collision of what we are doing right now, but about the rotation of the car. He coded that the rotation of the car basically in real time, instead of having the frames that you have. He said it, at the end, he's saying quick and dirty code, but it works. Yeah, would you like to have the source? So if you want to have the source, he is happy to share it with you, basically.
It depends if I can read the code, because I know that ProtonFig he usually work on Commodore 64.
Yeah, but
and I know absolutely nothing.
No, he also does Amiga. So I think he did it on the Amiga. Proton, I think you did it on the Amiga, not on the Commodore 64. I'm not sure. I mean, I'm just asking, but yeah.
If it's something that can be compiled on the Amiga, I'm very happy to
yes, he did it on a 500. So yeah. Yeah, I mean, send it and I will pass it to Ozzy, Proton, or send it in the on Discord to Ozzy. Yeah, it's fine.
Yes, so I'm very happy when someone shares the code with me.
So I went to the next slide.
Yeah, this is just the implementation of what I said before. This is the routine that checks if two cars are colliding. So first of all, I just reserve a long word for the data, I need a place to store the distance between the centers of the cars. Then I just move A0 to A2 and A1 to A3 because I'm gonna trash them later, because the sub2 the electrostatic macro trashes this register. So I have to save them and just restore them because that's how my routine works. Well, it's not the best idea. Probably I can tweak the code a lot and prevent all this move.l, but still I remember that move.l between register on the Amiga is very fast,
Yes.
so it's not
Yes.
a great performance issue, I think.
Mm-hmm.
So I think it's 4 cycles. Even if it's a long, it's very quick. So the sub2-vector static routine just stores the distance between the centers into distance between centers label, so this address of memory. And after that, as I said before, I just take the absolute value, and there is a macro for this, which is AES underscore work, which takes a word, so a memory location, and what it does, it's very trivial. It just checks if bit 15 is set or not, because this is what I use in order to compute if the number is negative or not. And of course, if it's negative, there is N68 instruction which is neg, which just do the one complement. I think it's English one complement.
Yeah,
just
negate.
To positive.
Yeah.
And that's it. Nothing more. There is a branch. I don't think there is a quicker way to do this because it's just a bit test and a branch and three instructions. So and of course this macro is repeated for the x and for the y. So the final result, the final outcome here is in the first 2 bytes of distance between centers, we have the absolute value of the difference between the x position and the y, the absolute value of the y is on byte 3 and 4 of distance between centers. And that's it. And this is the first part. Now that we have the absolute distance, the absolute values of the distance, we can apply the if statement. So if car width divided by 2 plus car 2 width divided by 2 is greater or less or whatever. So if you go to the next slide, it should be very easy to understand what is going on.
Mm-hmm.
So I take this mover wheelbase give offset. It's just the distance between the center of the car and the front wheel. So it's exactly what we need. It's the width divided by 2. I store this data in data register and then I add them. So D0 is just the car 1 width divided by 2 plus the car 2 width divided by 2. And you see that there is a SLL.W. This is a left shift instruction. And this is needed to normalize data because the mover wheelbase give to offset value is something that is the number of the pixels. So it's representing the pixels. So for example, if the sprite, remember, is 10 pixel wide width, we have 5 here. The value is 5. But the way that the game represents the position is reserving the 6 less significant bits for the decimal part. So in order to represent the number 5, I have to multiply by 64. And this is why I had to put this left shift instruction, because it's a quick way on the Amiga to multiply by 64. And the same exact concept applies to the height. height. I don't know how to say in English. Height.
Height. Yeah.
And height.
Yeah.
And so it's pretty much the same. So I get the width. In this case, I'm just assuming that the width is equal to the height, because if you remember, my cards actually, they are not, it's a rectangle, okay? But they are so close, so it's almost a square. So I'm neglecting the bit precision here. I don't care if there is a little bit overlapping of 1 or 2 pixels. I don't really care. What I just want the calculation to be very quick. So I'm pretending that my car is a square. This makes things even easier, and the code is even faster. Actually, I could do another optimization, just replace all this code with just one variable, which is the radius of a circle, for example. And I will get rid of all these instructions. This is something that I will take into consideration if I have performance issues in the future. So a small notice for me. And again, I have to left shift by 6 for the same reason. This is so when we are here, we have these values, and then we are ready to compare. I think in the next, if you go to the next slide, we can see the comparison. Okay, I also commented about the code a little bit. If the absolute x value of this vector is less than the sum of other, etc., etc., this is exactly what I was talking about before. If you see there is a cmp.w, actually it should be cmpe, because no, it's cmp. Cmp is good because I'm comparing the first 2 bytes of distance between centers with the 0. And some code is missing here, just taking into account that the 0 is the car width until yes. And if there is, it's less than, then I go to no car collision. And no car collision is just a label that iterates again. It's just a continuing C. So it just does nothing and go straight to the next iteration. The second check is equal. I just check the Y position, and if it is less than, I just go to no car collision. If these 2 checks fails, we are in the part when we must resolve the collision. So handle the collision and start saying what do we do with the collision. We must probably the cars must be separated in some way. This is my initial thought. And of course, I want the behavior of the car to change. For example, if one car hits another, the one with it, I want gain velocity, and the other must slow down. This is my concept. Try to go to the next slide. I don't remember if I put additional code here. And in the meantime, if you don't mind, I will just take a sip of water.
I do have a question for you, but not related exactly to what you are talking about. What software did you use to create these slides?
Software is Google Sheets.
Google Sheets. Okay.
Yeah, because it's.
I like. Also, I like the font that you use.
It's the default one.
Really? Oh.
Yes. Yes.
It's very good. It's very clear.
I don't remember if I told this before, but I program on my sofa with a Chromebook. And this means that I'm literally tied with the Google,
Yes, of course.
or I'm spied, of course, by Google. And for me, it's very convenient to use Google to do all this stuff.
So your emulator runs on Google also, on Chrome.
The Chromebook has this feature which allows you to run, let's say, a virtual container running Linux. And on top of Linux, I put FSUIE.
Ah, okay. Wow, an emulator within an emulator.
Yeah, but it works fine.
Yeah, of course, yeah.
Even if my Chromebook is an Atom processor, it's
Yes.
not the best of the best today, but still it has a great battery duration.
Yeah.
And I just paid this laptop less than 300 euros.
I have something similar. Yeah. Which is also has an Atom processor, and yeah, it does the job.
Yeah, they are not.
But
so fast
not it's
compared
not
to.
it's not a Chromebook. It's a Linux machine, but yeah, it's a
Yeah, the point is, if you buy a Chromebook, probably you are so tied to the Google environment that you have to use it.
yeah, and I am not a big fan of Google, so yeah, I mean I'm not saying Google is bad. What I'm saying is that Google today is fine. They have good things. Tomorrow you don't know. They might change, and they just, you know, you have to start again from the beginning. I hate that concept of Google. That's all.
Anyway, it's just my convenience. And
Yeah, sure.
use the tool that you prefer, really.
No, I like the
So-
font. It's quite a clear font when you are doing presentation. So that's why I asked.
Yeah, it was pretty clear to me.
Yeah.
No extra work, no time wasted looking for the right tools. It was already
Yeah.
it's enough. So. But again, this is not a program for Google programmers. We are
Yeah.
Metro programmers, so let's get back to our discussion about condition. And this is, I think it's the hardest part for me because I don't know how to explain this. So I apologize in advance if something is not clear here. I will try my best as always. There is this concept, and I don't know if it's right or wrong, which is called the shortest separation vector. And this is a vector that allows me to separate the two cars. Because, of course, when there is a collision, we are in a pixel world. We are not really in a real environment. So it can occur, for example, if at frame number 0, the car is not colliding, but on frame number 1, we can have the car entering, for example, right in the middle of the other car. This is something that can't occur, of course, in nature, but in the world of pixel is possible because how we represent the velocity is just adding pixels, adding position. So, for example, if the car is going to very high speed, I can say, for example, every frame I increment by 5 pixels. If the car is low, I increment one pixel. So if what we have, for example, while car 2 is still in the middle of the track, and there's another which is at the maximum speed, let's say 5 pixels per frame, it can happen that the car enters the shape of the other cars almost completely. So I want to separate this, and I want, of course, this is artificial, this is something, a tweak, let's say, of my code. And this is necessary because I don't want the next frame to repeat again the collision. I want the two cars separated, and since this is artificial, because it's a correction of the game, I want that the separation must be as small as possible. And this is where comes into play this concept that I came up with, which is car shortest separation vector. And I just want to describe a vector that if added to the car one position, it, let's say, teleport this car outside the collision space. I don't know if you understood something about my description. I know it's horrible.
I think I encountered this. I was doing something else. It's not recent, but I think I encountered this same thing, and you're just reminding me. So yeah, it does ring a bell to me. And by the way, Proton said that he sent the code to me, and because he didn't find you on Discord, but yeah, and I will share it with you. But yeah.
Yeah, but anyway, Proton, you can find me as
Ozzy,
in,
yes.
In the Phase 101 Discord server.
Yeah.
I am on all these channels.
Yeah, you can see him also. You can see him also on this Twitch as Ozzyboshi. So yeah.
Okay. Thank you. Proton,
Yeah, thank you, Proton. Yeah.
For your contribution. Please also tell me if this is public code that I can publish or not. This is important for me because I don't want to share things that I'm not authorized to share. So
yeah, because all the code of Ozzy goes to his GitHub, which is public. I mean, in fact, I gave him something recently, and although it's not public, but I said yes, it's fine. You can put it. But yeah, it's the same thing.
This is a big disclaimer. I usually share my code on GitHub, so remember that there is always this risk. If you give your code to me, there is a big chance that it will be public if I use it. So this is why I always ask for permission to share if I take something from another third party. So, go back to the shortest separation method. So, just to summarize.
So, is it the next slide or?
Just let me explain one more thing here.
Okay.
And then we can proceed. So, just the final goal is just to. I want to the next frame. I don't want the two cars overlapping. So this is just the goal. And the way I do this, I calculate this vector, this short separation vector. I add it to the car one position, and in this way, if my algorithm is right, it should not occur. So this is the concept. And this is how it works. I just calculate this this vector, which is made by two components, which are here defined as Sx and Sy. And the formula to get these values is the sum of the half width of the cars minus the x distance that we calculated previously. For example, here we calculate Sx is 10 pixels, and the y distance is, I don't know, because we have something in the middle, I think it's 2. And then I apply the pseudo C code that I wrote on the right. And the idea here is just to zero the longer axis. So for example, if Sx is minus this, then Sy, I just reset Sy. Else Sx is equal 0. Then I have to correct the sign because I have to manage if the car 2 is on the left or on the right, and also I have to manage if it's above or in the bottom of the other car. But I just change the sign. So for example, in this particular situation, the result vector is, if you do all the math, should be 0 for x and -2 for y. So, for example, imagine that you just apply this vector to the car 1. And so you have to move the pink rectangle on the x by 0, so it means by nothing, it remains the same, but you have to subtract 2. And again, when you subtract the position in this pixel wall, you are just moving up towards the upper of the screen. So it means that, imagine that the pink rectangle is just moved a little bit up, just that he doesn't collide anymore with the car number 2. And this is the concept. If you go to the next slide, there is another example of this.
Okay. Progetto Crema, yeah, it's fine, don't worry. Thank you anyway. Let's go to the next slide. There you go.
So, this type of diagrams is what I usually do before coding. So there is some preparation before writing code. I take paper and a pen, and I just draw all the possible situations that my code must handle. So in this example, the car 1 is on the left bottom side relative to the car 2. But still, I apply the same concept, the same algorithm. And if you do the math again, this shortest separation vector, it should be 0, 2. So 0x and 2 on the y-axis. So again, close your eyes, try to imagine the pink rectangle translated, so move it 2 pixels down, and this is how I solved the collision. The 2 rectangles should not collide anymore, and I introduced this, I think, very small error on the game. So, but as you see, it's always the same algorithm, and I think this comparison is just easy to handle for the Amiga, because you are just comparing 2 values, and resetting is just a move quick 0 into a data register, and also changing the sign, we have the neg instruction, so should be quite fast to calculate. I think I have a third example in the next slide. So
yeah.
I need some water again.
Yeah, I tell you. I always tell you, have water.
Yeah, this is another. Actually, I remember I did 7 or 8 different cases here. But of course, I just reported 3 of them, not to bother you too much, but just to say that before coding, I do all this type of preparation, let's say. before coding. So before going to bed, I usually read a book and then I start painting all this stuff and then I go to sleep. This is how it goes. So this is another situation. This time, the smaller axis is on the x, and the car 1 is on the top right, and car 2 is of course on the bottom right, and car 2 is on the top left. And if you apply again my algorithm, you have this result vector, which is 2, 0. So if you move the pink car to the right of 2 pixels, the collision is resolved. And so this is this concept of shortest separation vector. And in the following slide, we will see that I implemented this logic in assembler, and then I add these values to the car position in order to resolve the collision.
Shall I turn?
Please,
Yeah.
yes, turn the page. Thank you. Okay. As I said, the separation vector is where data goes, so where the outcome of my algorithm is stored. I set into A1 the mover position, and the mover is car 1, so the first car. And I just perform add to the vector. So now the cars should be separated. Then this is something that I figured out on my own, actually, really totally invented, no clue why I did this, but the outcome was pleasant to my eyes, so I did it. And what I do here is the following. I take car 1 velocity and I store the vector into data register D1 and D3. Then I get the half of the velocity. You can see that I have this ASR, so there is some mathematical path shift just to get the half of this vector, better than use div or divs. And then I add the resulting vector, so this shortest vector, to the velocity of the other car. So it means that if you have a car at low speed, which gets bumped by a car who's going full speed, for example, this vector is transferred from the car 1 to car 2. So car 2 must accelerate because it was hit by another. And what about the other car? So the car which was picking up at great speed and was going very fast. I just subtract the same value, the vector, so divided by 2. So the final result is the car 1 just gets a little bit slower because he encountered an obstacle, and this obstacle is causing the car to slow down over time. On the contrary, the other car, which was going at a slower pace, gets some velocity, so I add this vector, and it should speed up. This is how the game mechanics works, more or less, let's say. Of course, there are some constraints, because the car 2 have this concept of max speed. So if it's already going nearly max speed, the resulting vector will be something on average. For example, if it's going at full speed to the right and is bumped on the top, it should get in the middle. So at, for example, the resulting velocity vector should be 45 degrees. And so, and this concludes my presentation of my work that I did on the last weeks. I just want to remind you that if you are interested in the project, on the bottom of this slide there is a link, and this is the full source code of this, what I talked about tonight. So there is all the concepts that I explained here are just implemented on this file. And of course, if you don't like the way I handle collision, you can just clone the repository and write your own collision detection routine and the collision behaviors. And so, just one final thing. I had some requests to talk about how the sound is generated by the cars. I think I will talk about it in the future. Unfortunately, I didn't have time to prepare the slide for this thing. And additionally, right now it's just a preview. I'm implementing a new method for loading the track data, so you can copy your IFF files into a specific directory, and the game in the future should be able to read the images, and so you can easily add your tracks and circuits and as much as you want. So this is just a preview of what I would like to talk about next time. And of course, this time will be a little bit different because I will talk about DOS library. And this is something related to the OS and not properly something that RamGen talks about, but there is a paragraph, I think, a chapter that describes how to load files from the disk, how to re-enable the OS, just some complicated stuff. So hopefully I will succeed doing this. I'm still in the middle. So that's it. If there are no questions, I will say that's all for this time.
Okay, so first of all, thank you, Ozzy. That was quite interesting. Excuse me. Yeah, this what Ozzy mentioned. If you look it up about collision detection using software collision detection, basically, you'll find these methods in a number of ways. I mean, you will not find it in assembly, but you will find the or at least I've never seen it in assembly. Let's put it this way. I saw it in 8086, but yeah, not 68,000. But the principles are the same, and yeah, you can use them. And yes, he mentioned the square, but you can use sphere to have better collision detection. It's faster. I think it's faster. I mean, I've never used sphere myself, but I think it's faster or more precise.
The problem arises if you have very complex forms.
But yeah, you will. You can look them up. They can go to very complex ones also. So for the Amiga you cannot go to the complex ones because you're limited by processing power. But on PC, of course, it's a different story. So you can do that. So let's do this. Yeah, I will continue to stream. Probably I will stream tomorrow. I don't think I will stream on Thursday, and I will not stream from Thursday till Sunday. Then I should start again on Monday. Unfortunately, this week is quite an intensive week for me, so I cannot really stream and continue with the 68,000 learning 68,000 with Dockster as I was doing. But yeah, it will be from the Sunday after, and during the week I stream either Ozzy or the book. So thank you very much, guys. Have a nice lovely week, and see you tomorrow. Bye bye.